Hello, I'm looking forward to this chapter. Geometry has always been my favorite. So today we're going to talk about angle measurement. In geometry, the word plane is used to refer to a mathematical concept describing an infinite set of points in space. So you can think of a plane as a sheet of paper, but that extends forever and ever and ever and ever. An angle is a measure of the size of the opening between two intersecting lines. So the lines, called rays themselves, are not the angle. It's everything inside that's shaded in light blue there. Excuse me, my pencil stopped working. The two lines are called rays, and we also call them the sides. And where they meet, that point is called the vertex. An angle can be identified in any of these ways. So the first picture, we're looking at angle ABC. And we notate an angle with a little bitty angle out front. You can also notate an angle with just the vertex, just the point at the vertex, as long as there's not any other angles attached to it. Like if we had another angle coming out here, then you wouldn't know which one was called D, so you wouldn't be able to name it that way. Or you can call an angle with a little letter or a Greek symbol. Sometimes you might see theta or something like that, that's inside the interior of the angle close to the vertex. The interior of angle POR, or you could call it ROP, either way, is shaded. And the interior of angles A and 1 are shaded here. Not really anything to do with this, just pointing out some things. Now, I also want to point out when you name an angle with 3 letters, the vertex has to be in the center. So we could call this angle POR or angle ROP, but not any other combination of those letters. Measuring angles when naming or labeling an angle is the first step. Measuring it may be more important. Angles are measured according to the size of their opening. The length of the sides are not related in the size of the angle. So both of these angles here are the same measure because their opening distance is the same, even though the second one looks smaller because its lines are shorter. The angles are still the same size. And sometimes you'll see angles that are measured the same with little marks like this, or with 2 little marks. That's meaning they have the same measurement. The basic unit measurement of an angle size is the degree. You could also have radians, but we won't go into radians, I don't think, here. So we'll just talk about degrees. Radians would be if you're taking trigonometry. Because of traditions going back thousands of years, we defined a degree as an angle that is 1/360 of a full circle. And if you think about the calendar, if you think about space, any circle, everything is divisible by 6 or 12. And that's where that 360 degrees comes from. The degree can be further divided into smaller angle units known as minutes and seconds, which are not related to time units, by the way. But still, 60 seconds is a minute. And 60 minutes is a degree, not an hour in this case. We denote minutes with 1 little asterisk. Seconds are denoted with 2 asterisks. So an angle of measure 62 degrees, 12 minutes, and 37 seconds would be written 62 degrees, 12, 1 asterisk, and 37, 2 asterisks. As we started talking about in the previous chapter, a protractor is a device used to measure angles. So if you had an angle DEO, then you could line it up on the protractor and see that it is 60 degrees. And we don't say, I know there's a 120 there also, but because it's on the left-hand side of 90 degrees, then we measure counterclockwise. And it's obvious that it's a smaller angle than 120 degrees. While if we were measuring angle BOE, because we're coming from the right, we are also measuring counterclockwise, and that one would measure 135 degrees. To measure an angle, place the protractor where the vertex is in the middle and one of the sides is along the horizontal there. Find the measure of each angle. So we're looking first at angle EOB. That's this angle. And so since the ray or the side is on the right over here, then we need to measure counterclockwise, and we can see it's 135 degrees. Then we're asked to measure AOD. So this time we're starting and going clockwise, and it measures 120 degrees. An acute angle is a cute little angle. It is smaller than 90 degrees, and an obtuse angle is bigger than 90 degrees. A 90-degree angle is also called a right angle, and we denote that it's 90 degrees or a right angle. This little box here. Two lines that meet in a right angle or 90 degrees are said to be perpendicular. And a straight angle, just one that's a straight line, is equal to 180 degrees. To draw an angle, you start with one side. And then if you've got a certain measure you're trying to have, then you're going to place your protractor on top of it. And then kind of mark with a little dot or something the angle that you're looking for. This one was 30 degrees. And then connect that dot with the vertex. Some angle facts. Here, in this particular picture, angle A is 30 degrees, and angle B is 150. C is 30, and D is 150. Can you tell then if A is 30 and C is 30, they have equal measures. And B and D are 150. They have equal measures. And that is a theorem, we call it, called the vertical angle theorem. For any pair of intersecting lines, the opposite angles are called vertical angles, and they are always equal. Adjacent angles are angles that are adjacent. They're right next to each other. So like P and Q are adjacent angles. They share a side. And then if two lines intersect so that you have adjacent angles, then they add to be 180 degrees. Also in a triangle is three distinct line segments with three angles, And the line segments are called the sides, and they meet at vertices, just like the vertex of an angle. And if you'll notice, if you add the measures of the three angles in a triangle, it always equals 180 degrees. So the interior angles of a triangle always add to 180. And here's a little picture proof for you where they took the angles, separated them out, and stuck them together, and you can see that it forms a straight line. Example 3 says, if angle P is 50 degrees and angle Q is 85 degrees, find angle R. So we would take 50 degrees plus 85 degrees plus angle R, and I'm not going to put the little slash through it. I'm just going to draw it like that. You'll see it both ways. They would add to equal 180 degrees. 50 plus 85 is 135. And then you would subtract 135 degrees from both sides, and the measure of angle R is 45 degrees. And here's another example. So here we have that the measure of angle P is 27 degrees and 42 minutes. And the measure of angle Q is 76 degrees and 25 minutes. So we can say 27 degrees and 42 minutes plus 76 degrees and 25 minutes plus the measure of angle R will be 180 degrees. Now, the minutes trip us up a little bit here. So everything either has to be in degrees, where we change the minutes to decimals, or everything has to be in degrees and minutes. So in that case, we could take the 180 degrees and change that to degrees and minutes. If we had said 179 degrees and 60 minutes, that's the same thing, because 60 minutes is 1 degree, and 179 plus 1 is 180. So that would work for us. So add, and we've got 103 degrees and 67 minutes. And then we'll subtract 103 degrees and 67 minutes from both sides. And so angles R measure will be 179, 179 degrees and 60 minutes, I wrote that wrong, minus 103 degrees and 67 seconds, or minutes. Ugh. Notice when we perform that subtraction, we would get 179 minus 103 is 76, and 60 minus 67 is -7. Well, that doesn't really make sense. So what you have to do is take that -7 from a degree of the 76. So it'll take the 76 down to 75 degrees, and then 60 minus 7 is 53 minutes. Angles formed from parallel lines. So if you have two parallel lines, and they're parallel if they're the same distance apart and they never cross, and they're cut by a third line, which we call the transversal, then several important pairs of angles are formed. We have alternate interior angles like C and F or E and D. Alternate being on opposite side of the transversal, and interior on the inside of the parallel lines. Now, we don't usually talk about alternate exterior, but they do exist. It would be this angle and that angle, or that angle and that angle. But we don't usually talk about it. We go straight from alternate interior and then use the fact that they're vertical and still would be equal. Then you have corresponding angles. So corresponding angles are like A and E, or B and F, or C and G, or D and H. And notice how I put the marks on there so that you could see that those angles are equal. They are. That's another theorem, or as we're calling here, a rule. When parallel lines are cut by a third line, a transversal, the corresponding angles are equal, and the alternate interior angles are equal. So example 4 says, a plumber connects two vertical sections of a pipe with a 30-degree elbow. What angle does the elbow make with the upper pipe? So if we extend the horizontal and vertical lines, like down here, then you can see we've formed a right triangle. And we're trying to find, it says, what angle does the elbow make with the upper pipe? So we're trying to find the measure of this angle here. Okay? Well, before we could do that, we can find the measure of angle C. We know the angle B, because we drew straight out from a horizontal and vertical, is a right angle, or 90 degrees. So we can say 30 degrees plus 90 degrees plus angle C is equal to 180 degrees. So angle C's measure is 60 degrees. And then we can find X because this is a straight line. So what we've got here is we've got a line, and we just found angle C to be 30 degrees, and so now we're going to find X. And we know that angle X, which we're just calling it X here, plus the 30-degree angle will be equal, oh, it was 60. Oops. The 60-degree angle, oh, sorry about that, that equals 180 degrees. So if we subtract 60 from both sides, then the measure X is 120 degrees. And that's it for this section. That was nice and short.